All right, so I'm going to start with our water tank example that we kind of got partway through last time. So at the very end of class last time, we introduced the for loop and we said we need to now be able to use our index variable for our for loop. So where is our index variable here? Or what is our index variable? The tank is our index variable. And our index variable is the thing that's changing in our for loop. So the for loop repeats a certain number of times. In this case, we're repeating 3 times because we have 3 water tanks. And our tank variable is the thing that is changing inside of our for loop. The first time we go through the for loop, tank is 1, and then it's going to change to 2, and then it's going to change to 3. And so we're going to use that tank variable to help us do what? Do you remember? What was the purpose of putting the 1 comma tank here next to R and next to D? Yeah?
This was a vector.
Right, so R and D are vectors, right? We have those declared up there at the top. I'm going to turn the lights down. Oh, of course, it's the last one. So if R and D are vectors, why are we going to put 1 comma tank next to R and 1 comma tank next to D? What does that help us do? 1 gets us the first row, right?
Yeah.
And then R and D have 3 columns, right? So we want to change from the first column to the second column to the third column, and the tank variable, because we have that in the for loop and it's going to be changing, that's going to help us do that. So everywhere in this problem that we have an R and we have a D, we want to put the 1 comma tank at the end of it. So we could go through and copy and paste and put it after every 1 comma D, but you know that's kind of tedious and we might miss one. So what's the easiest way to do it? Well, MATLAB has find and replace capabilities. So you can just hit Control F on your keyboard. You can search for little d. If you click the match case button here, check mark here, it'll look for only small lowercase d, not uppercase d. And then I want to replace little d with little d 1 comma tank. And then we can go through each one of those, find the next one, replace it, and then just replace all the ones that are appropriate.
How do you open the...
I did Control F, so who knows what to do on a Mac. But however you get that magic to happen. So you want to replace all the D's with 1 comma D, except for the one up at the top where we define the vector for D. That one stays the same because we don't want that one to only be 1 column. And then we can do the same thing for the big R. So we can find big R and replace that with capital R 1 comma tank in all the places that we have it. And then there's a couple more places where we're going to put 1 comma tank. Oops, I got one extra one in here. A couple places, other places we're going to put 1 comma tank. So we also want to put that on our outcome variables, or the things that we're trying to calculate. So all of our volume variables, we also want to put 1 comma tank, because then that will create us a vector of volume values, and they will match up with our input. So for every input that we get, we'll also get a corresponding output. So next to all of our volumes, I'm also going to put a 1 comma tank.
I clicked replace all.
See, replace all is dangerous because it's going to replace all anything you have that's a D or an R in your whole code, which is a little dangerous because you probably have them in your comments or whatever. So I usually try to just replace one at a time and then avoid the replace all disaster. So what else are we going to need? We only have one end statement here to end our if-else. We also need another end statement to end our for loop. So after the if-else end, we put in another end, and that completes our for loop that we have. Now if we want, usually we have stuff inside of a for loop kind of indented over. Rather than going through and doing the indentation for all these lines inside of here, I'll show you a little trick. So if you highlight all of the code in the for loop, and then you press on a Windows machine, Control-I, good luck for you Mac people, it will indent all of that stuff automatically for you. So Control-I is a nice handy trick for just doing indentation, and you can highlight all your code and press Control-I, and MATLAB will automatically indent the whole thing kind of the way that it likes it automatically. So Control-I is a handy thing. All right, so should we try it and run? Why do we have all the yellow, right? So here is where our traffic light is kind of telling us that we might be doing something wrong or MATLAB's unhappy about something. So let's put our cursor over that and we'll see what's happening. So if we put our cursor over any of these volume variables, it doesn't matter. They all have the same message. MATLAB's saying, Mohammed? MATLAB's saying these variables appear to be changing every loop iteration, changing size every loop iteration, and MATLAB says consider pre-allocating for speed. So what is MATLAB telling us? MATLAB's telling us that first we're going to have in VTOP, we're going to have one number, then we're going to create a vector, and we're going to have two numbers in there, and then we're going to create a vector and add to it, we're going to have three numbers in there, and it's kind of not so happy about that because we're changing the size of it. Honestly, for this class, I don't care about this error. I don't care about this warning. This is one of these warnings that you can ignore. We're not going to be writing, it becomes important if you're writing really, really long programs that take a really, really long time to run, and then these kind of things make a difference. For the short programs that we write for this class, I don't care. So if you see this warning, you can kind of ignore it. If it really bothers you, what you can do is you can do what's called pre-allocating the size of the variables. So I'm going to show you how to do it, but this is totally optional. So you can do this for all the volume variables. And basically what we're going to do is we're going to create the vectors for VTOP, VBottom, and VTotal, give them kind of dummy values of 0, and just let MATLAB be happy that we've given it some space, and then we're going to fill it in with the actual numbers later. So for each of our volume variables, so VTOP, we're going to set that equal to, using our zeros function, 3 zeros, 1 row, and 3 columns, just like that. And then that's just kind of a placeholder for MATLAB to say, I've created this vector, I put zeros in it, now you can fill it in with some other things, and it's happy with that. So I can do that for VBottom also. And then VTotal. So I'm going to put up here in the comment, this is optional. You don't have to do this step. It's just in case you really don't like seeing those warnings over there, you can do this and get rid of it.
Why does this work?
So this basically just tells MATLAB I've got this variable and it's going to have stuff in it. I'll give it to you later. So right now I'm just going to put zeros in it and kind of hold that space. All right, so are we ready to run? What do we think? Save first, right? And then since this is a script, we can just hit our magic run button up at the top, right? And we'll see what happens. Uh-oh, I forgot a thing here. So what's MATLAB telling me? MATLAB's telling me that I forgot to do something. So I got this subscript assignment dimension mismatch error. Usually that means that I forgot to put my row and column somewhere that I should have. So that's what that error usually means. So let's run it now. All right, so we had one tank overflow, which we kind of knew, right? If we go back up to our inputs, The third tank that we had was an overflow, so we only got one overflow message, so that was good. Let's look at our VTotal variable. So if we open that up, we told MATLAB we wanted 3 values, right? We said we have 3 tanks, we're going to want 3 values. We got 2.0 for the first one, we got 19.7 for the second one, and then we got 0 for the third one. So why did we get 0 for the third one? Because it overflowed, and then we didn't give it a value, so MATLAB kept that 0 kind of placeholder in there. So we did okay, right? How do we feel? Good? So now we've written this code, and you may still be kind of wondering what the heck is MATLAB doing when it's using an if statement or when it's using a for loop. So I'm going to show you kind of a nice thing that helps you step through MATLAB code exactly how MATLAB's doing it. So one step at a time, and then you can kind of see where things are happening in the code, what's happening when MATLAB's running this, and it's not just so much magic. And this is also a good way to kind of troubleshoot. So if you have something, you've written the code, and you're not really getting the answer that you expect to come out of the code, you can use this as well to help you kind of troubleshoot those things. And so this is called a keyboard. So I'm just going to add in the word keyboard into my code. And what this does is once we save this and we run it again, we go into what's called keyboard mode, and that allows us to execute the MATLAB code one line at a time. We go through it step by step exactly how MATLAB does, and we can kind of interact with it through the command window with our keyboard, which is why it's called keyboard mode. So we stick the keyboard in there, save it one more time, and now we hit run again, and you'll see that rather than just kind of running through the code and spitting out our answers, MATLAB stopped. And so down here in the bottom left, we have waiting for input. So that's MATLAB telling us that it's stopping and it's waiting for us to do something. What it's waiting for us to do is kind of step through it one step at a time. And the way we can do that, now you can see up here at the top, I've got some extra buttons that have popped up. And these only appear when we're inside of this keyboard mode, or if you have done other programming, this is kind of analogous to putting in like stops or other things that they call it in other programming languages. And so what we can do is we can hit kind of 2 of these buttons are really useful. Step lets us step one line at a time through the MATLAB code. So if we hit step, we're going to go down to our VTop. And if we hit step a couple more times, you'll see that as we go through that, those variables are showing up over in the left on the workspace, like one at a time. We've got VBottom now coming up. We've got VTotal coming up. And so we can see kind of how MATLAB is doing this, creating those variables one at a time. If we were to put our cursor over any variable that we have, we also can kind of see the real-time live values that are inside of that variable. So we created VTop, we told it to put 3 zeros in it, MATLAB did that, so we're pretty happy. And now we get down to our for loop. And so this is where, the keyboard's really helpful. We're kind of just understanding what a for loop is actually doing. So for loops are repeating things a given number of times. So we told MATLAB we wanted to repeat these calculations for the volume 3 times because we have 3 water tanks. So the for loop is going to hopefully repeat 3 times if we've set it up correctly. So once we get to our for loop, we press step one more time. I get down to this if statement. And now this is where MATLAB's going to be asking the question, is D greater than R and is D less than 3R? And so it's not doing that for all the values we have in D. It's only doing that for the first one, because if we look at tank right now, tank is equal to 1. So if I were to, for example, execute this line of code, just the D 1 comma tank, that only tells MATLAB that D is 1.25, which is the first row, first column in D. So it's only looking at that first tank at this point because we're in the first iteration or the first repetition of the for loop. So it's only looking at the first value of D, it's only looking at the first value of R when it asks this question. And so is that true? So is 1.25 less than 1.3 or greater than 1.3? No, not for that tank. So what's MATLAB going to do? MATLAB's going to skip over that entire if statement. That expression was false, so it skips over it. It goes down to the next else if, and that's where MATLAB's going to ask the question, is now 1.25 less than or equal to R? Yes, that's true. So what we should expect is that MATLAB now doesn't skip over, it goes inside of that if-else statement and it starts to go through the code that we put inside of that if-else statement. So it's going to calculate the bottom volume, it's going to calculate the total volume, and then it skips over that else statement because it's done. We told that was true, that one statement was true, so MATLAB doesn't check any other if-else statements that are after that. It just skips over them, and now we get to the end, the bottom of our for loop, and so this is where MATLAB says, okay, do I need to repeat another time? Yes, because I only did it one time, and we told MATLAB to do it 3 times, so it's going to have to repeat again. So if I hit step, what's going to happen is it's going to go back up to the top of the for loop, and now tank has changed to be the value of 2. Because we finished the first repetition, now we've gone on to the second repetition, and it's going to repeat this process again. So it's going to go through the if-else statements, but now instead of D being 1.25 and R being 1.3, we've moved over to the second column. D is 3.8 and R is 1.5, and now we got to ask these questions for that water tank. Is D greater than R and D is less than 3R? Yes, this time. So this first if statement is true. If we step through, it's going to calculate the volume with these 3 equations. It skips over the other ones because that first one was true, so it doesn't need to check the rest of them. And then we get to the bottom of the for loop. We repeat for a 3rd time. Now tank is equal to 3, and it goes through these questions again, right? The first one, false. Second one, false. Third one, we got to go there by default because that's our last else. It always happens. And then we say, okay, what do we want to do here? We want to display that it was an overflow. I hit step one more time. I get to the bottom of my for loop. I've done it 3 times already, so MATLAB's going to be done. I hit step one more time, and we're finished with the program. We're completely done. So that's kind of how MATLAB's stepping through. It's using for loops. It's using the if-else statements. And so the keyboard's really helpful, I think, to kind of wrap your brain around what MATLAB's actually doing. You know, it's got a process. It's going through this, asking these questions, and it's not just MATLAB magic that happens. All right? So any questions about for loops or if-else statements at this point? All right, let me throw one more, wrench in the plans. So what if I decide I only wanted to evaluate 2 water tanks? How many, or what should I do now to change my code? Change my zeros, right? So instead of having 3 here, I'd change that to 2. What else do I need to change? The tank, right? So instead of tank going up to 3, I only want tank to go up to 2. Well, that's kind of annoying that I have to go into my code and I have to change it every time, right? So what I usually do here is instead of using actual numbers to tell MATLAB when to stop, I get MATLAB to tell me what those values should be. So does anybody remember how we calculate the length of a vector? That was a function that we learned back when we learned functions. Length is the name of the function to calculate the length of a vector. So that one's easy to remember. So what the length function does is it tells us how many, or what's the longest number of elements that we have in a vector. And so in this case, if we take the length of R or we take the length of D, we'll get 2 or we'll get 3 or we'll get 8, how many ever values we have in there to represent how many ever water tanks we have. And so that will change depending on what we've given MATLAB for R and D. So instead of just having 3 or 2 or whatever number it is, it's usually a good idea to use the length function inside of that zeros function. So we could take length of R and put that in for all of those 3's, and then MATLAB will calculate what the length is, and we don't have to go through and change our code if we change the number of water tanks that we're trying to evaluate. And you could have done length of D or length of R, it really doesn't matter. So I'm going to replace the 4 places that I have a 3 with length of R, and then every time I change, if I want to do 1 water tank or 2 water tanks or 1,000,000 water tanks, MATLAB will be happy, and this code won't have to change at all. It's a nice kind of flexible way of getting the code to change. So if we save this and we run it one more time, even with the 2 water tanks, oh, we still have the keyboard in there. So if you have a keyboard in there and you don't want to step through one at a time, you could just hit continue up here, and MATLAB will just go straight to the end. And then what do we expect? If we look at VTotal, we now only have 2 values because we only had 2 water tanks. So our code worked, is now more flexible than we had before. All right? So, any questions about that? Okay, so what we're going to do right now is we are going to start the in-class exercise. We'll do that for the rest of class today, and then, on Monday, work through the rest of it. There are 5 problems in this in-class exercise. So the first 2 are similar to what I've asked you to do for your next homework that's due on Wednesday, so homework number 4. On problem 1 and problem 2, it's on here, so you don't have to necessarily remember what I said, but you don't have to use a for loop. Problem 1 and problem 2 are just really testing if-else statements. So you've got one input value, not a vector, just a scalar input for both of those. Write the if-else statements, see if they work. Then there's a kind of error debugging problem that you can write the answers on the assignment. And then problem 4 and problem 5 are to kind of turn that into a problem that would work for a for loop. So take problem number 1. Now if I give you a vector of inputs, what are you going to have to do to be able to make the code work for that? So that's what the in-class exercises are. All right? So we'll get started on these.